In this section, we're going to be talking about linear inequalities, but first we need to know what is a linear inequality. Well, it is very similar to a linear equation, except it uses inequality symbols. All right, now, what is a solution to linear inequality? A solution to the linear inequality is where the shading happens. It's where the shading happens, and it's all ordered pairs that make the inequality true. Inequality true. So let's test that. Let's look down here for an example, and it says which ordered pairs are solutions to the linear inequality below. So this is very similar to what we've been doing. So if x is 2 and y is 5, so I'm going to rewrite the equation in all of these because we're testing these ordered pairs with the same inequality. And now I want to plug these in. So if x is 2 and if y is 5, does it make 4 minus 15? Is negative 11 less than 15? Yes, so that is true. So this is a solution. Okay, now let's look at this one. If x is negative 1 and y is negative 7, does it make this inequality true? Is negative 2 plus 21, so 19, is 19 less than 15? No, that is not a solution. What about 3 and 4? If x is 3 and y is negative 4, does it make this inequality true? Is 6 plus 12 less than 15? No, 18 is not less than 15, so that is not true. Last one over here, if I give 0 is an x and y, or 0's for x and 0's for y, 0 minus 0, 0, is 0 less than 15? Yes. So the two examples that make this statement true are 2 and 5 and 0 and 0. Okay? Now, how do we, there's got to be an easier way though, right? There's got to be an easier way than to test every individual point. So how do we graph linear inequalities in a way to show all the ordered pairs that it represents? Well, first you're going to put it in y equals mx plus b form. So you're going to put it in slope-intercept form, y equals mx plus b. Now, remember when you flip the inequality. Anytime you multiply or divide both sides by negative, you got to tell your brain, I flip my sign, I flip my sign. Step 2 is we're going to graph the line. Now, here is going to be the new parts for you guys, okay? When you use a solid line, you use a solid line for less than or equal to, or greater than or equal to, or less than or equal to symbols. You use a dotted line for greater than or less than symbols. Now, the shading. We shade above the line for greater than or equal to, and we shade below the line for less than or equal to. So if you look at number, let's do this example together on this one here. My first step is I have to get y by itself. I have to get it in y equals mx plus b form. So I'm going to subtract 2x on both sides. I get negative 3y is less than negative 2x plus 15. To get y by itself, I divide by a negative 3. You are dividing both sides by a negative, so remember, you got to flip your sign. This sign becomes greater than, and I'm left with y is greater than 2/3 x minus 5. So this part you've done before. You know how to graph the line. So I begin at negative 5. My beginning point's negative 5, y-intercept, and my slope is 2/3. That doesn't change, right? So I begin at negative 5. My slope is up 2 over 3, up 2 over 3. And now, is it going to be solid versus dotted? because it's greater than, it's not equal to. If it's equal, that means it's a straight line. But this is not equal to. It's just anything greater than. So I'm going to use a dotted line, go all the way through. Okay? That's a dotted line because it's greater than. Look at the shading. If it's greater than, we shade above, which makes sense. Greater than above, less than below. Less than, right? Now, how do you determine if it's greater than or less than? Remember our skier. Our skier skis left to right. So if I drew a skier in here, he starts on the very left-hand side, and if it's greater than, you shade the sky above him. If it's less than, you shade below, which is the mountain. And in this case, it's greater than, so I'm going to shade above. So all of these points are ordered pairs that make this equation true. So how do you test it? Well, I would test it by choosing an easy point. An easy point for me is 0, 0. So if 0, 0 is true, then I've shaded correctly. So I'm going to plug in a 0. So 0 minus 0 is less than 15. 0 is less than 15. So I shaded it above. So I shaded it pretty good so I can test myself. So the only thing new in here is dotted versus solid and shade above or below. Okay? Let's do some more together. All right. Let's look at number 1. This is already in y equals mx plus b, so negative 5. And my slope is 1/3. So up 1 over 3, up 1 over 3, up 1 over 3. And now I can go the other direction. Now, solid or dotted? Because it's greater than, it's a dotted line. Only if it's equal to is it solid. So I'm going to make a dotted line all the way through, arrows on both ends. I'm going to add my skier because my skier makes it easy to determine if I shade above or I shade below. Remember, your skier always starts on the left-hand side. There's my skier. And it's greater than, so I shade above. So all this is above. So you'll notice this point right here is x is 0, y is negative 5. If I use that as a test point, it better not make my equation true because this is a dotted line. Watch what happens. If I plug in negative 5 for y and 0 for x, negative 5 is not greater than negative 5, it's equal to. That's why it's a dotted line because these points on the line don't make the equation true. Okay? All right, let's look at number 3. My first step is I have to get y by itself. So I'm going to subtract both sides by 5x. Negative 2y is greater than negative 5x plus 12. I divide everything by a negative 2. Remember, this rule doesn't change. If you divide both sides by a negative, you must flip your sign. And I get y is less than 5/2 x minus 6. So I begin shading at negative 6. And my slope is 5 over 2, so I go up 5 over 2, up 5 over 2, up 5 over 2. Solid versus a dotted line. It's less than. So that the points on the line cannot be a part of that solution. So it is a dotted line because it's less than. I'm going to add my skier. Remember, he skis left to right. So there he is. And this is y is less than. So I'm not going to shade above him to the sky. I'm shading less than the skier, below the skier. So now all these points here are shaded. And I can pick any point I want. I'm going to pick this point right here. And that's 3, 6, 7. I'm going to choose that point. And that point is 7, 0. And that better make this equation true. So if I plug in a 0 for y, and a 7 for here, that's 35 over 2, 35 over 2 minus 6. So 35 over 2 is 12.5. 12.5 minus 6 is 6.5. 0 is less than 6.5, so it's true. I mean, I picked a bad one because it didn't come out even, but you see how I'm testing that point. Okay, let's look at number 5. So my first step still is to get y by itself. So I'm going to subtract x on both sides. I get negative y is greater than or equal to negative x plus 8. Y is negative, so remember, this is where we flip out. I flip everything, and I get y. I'm dividing by a negative, so I flip my sign, and I flip everything around it. Okay? So y is less than or equal to x minus 8. So my beginning point's negative 8. My slope is 1 over 1. So now, look at this. It's less than or equal to. If it's equal to, it's a solid line. Solid line is equal to. So notice I get a straight line. That means any point on this graph is going to make that equation true. Any point I choose, it's going to make that equation true. And so now, let's bring back my skier. It's less than, so am I going to shade above the skier or below the skier? Well, it's less than, so I'm going to shade below the skier. So all these ordered pairs are true, okay? All right, let's look at number 7 and 8. What does the graph of this look like? Well, he's alive. My beginning point's negative 4. It's a 0 slope. It's an equal, so y is less than or equal to. Here's my skier, and y is less than means we shade below. Right? Okay, now, look at number 8. Remember what the graph of this looks like. You will go to 7, where x is 7. It's going to be a dotted line because it's just greater than. It's not equal to. And then students are always like, well, where do I shade? It says x is greater than 7. Do I shade above or below it? This is where common sense comes into play. Look at it. If x is greater than 7, it means x can be 8, 9, and 10. X is going to be all of these that are greater than 7. Okay? These numbers over here are less than 7. This is greater than 7. Okay, so that's a little bit about linear inequalities. If you're struggling, come see me.